Okay. Let's take a look at our calendar. Yep. All right, today is the 15th. We're going to get through 6.1 today. Might even get through some of 6.2. And then you have a wrap up tomorrow. There's no quiz or anything. Dr. Cole will be here on Friday. And on next Tuesday, I am working on some review questions. They're going to be different because I didn't find any from Alex that I wanted to use. I just wrote them myself. So they're going to be my own kind of, let's say, quirky style. And so you'll go through those on Tuesday. And that's it for now. Homework due on Saturday and Monday and the wrap up due. Any questions about the calendar? All right. So stop share. We are recording. All right, let's talk a little bit about section 6.1. Which is called function algebra. I like function arithmetic better, but we'll stick with algebra. Autofocus. 6.1 function algebra. It's really just arithmetic, adding, subtracting, etc. And there's just a couple of things I want to make note of. In this chapter, we do 4 types of operations. We add, subtract, multiply, and divide functions. Part of this, I think, is just getting used to the notation. So if I have f of x equals x squared plus 2x minus 8, what kind of a function is that? It's a quadratic. And g of x is equal to the square root of x minus 2. That is what type of function? Yep. Then we can do a bunch of different things. We can do something like f plus g. Then we put parentheses around them. This section and the next section are where parentheses are going to get a little bit out of control. And so you really kind of have to slow down and just memorize what each different but similar notation means. F plus g of x just means take your outputs from f of x, take your outputs from g of x, and add them together. So that's equal to x squared plus 2x minus 8 plus square root of x minus 2. Outputs of f, outputs of g, add them together. Let's do g minus f of x, because yes, you can do these in opposite orders. That's just outputs of g, and then subtract the outputs of f, which is, and the reason I'm doing it this way is because this is one of the common mistakes, and it came up last time in logs as well. Order of operations, what do you do with parentheses? You're subtracting the whole function, x squared plus 2x minus 8, and you're subtracting it. So if you were to simplify, it'd be minus x squared minus 2x plus 8, as that minus goes through. We could do gf of x. Sometimes you'll see a dot there, sometimes you won't. That's take the outputs of g, multiply them by the outputs of f. So that's square root of x minus 2 times x squared plus 2x minus 8. And we can do f over g of x, parentheses, all over the place. Take the outputs and divide them. x squared plus 2x minus 8 over square root of x minus 2. Okay, so I happen to do f over g here. You could combine them in the other way if you wanted. I did g times f. You could combine it in the other way if you wanted. Any questions about that basic notation? Okay, so there are, oops, that's music. Sorry, that's also music. There we go. I'm running short on scratch paper. I'm going to give you all a cheat code for 6.1 and 6.2. And that cheat code is don't simplify. I'm going to put that in quotation marks. Don't simplify. Simplify itself is a word which means make the function easy to use for the purpose you are trying to use it for, right? So if I took a cost function and a revenue function, so the revenue based on the quantity, right? Let's say that you're selling OSU beaver hats and you're the beaver store. You're the only one selling OSU beaver hats. So what happened? Are you able to raise your price if you want? You can because nobody else is selling them. But what happens when you raise your price? Fewer people buy it. So your revenue goes up when you raise the price, but then it comes down when fewer people buy it. What shape does that make? A U, what kind of function? Quadratic. Monopolistic selling is quadratic. And it opens down, so it should have a negative. So it might be something like minus x squared plus x over 4, something like that. You often see something like that. And if you're making beaver hats, it costs you more to make more beaver hats, but you also need to rent the space. So you have an initial cost, let's say, of $100. And then every time you make a hat, it costs you half a dollar. So here we have two functions. And what's revenue minus cost? Profit. So we can do a profit function. Profit usually uses pi, because pi has a p sound, but p is for price. Pi of x is the profit. Right, so this is revenue. Revenue means money before expenses, right? Money coming in before costs. And wait, what's profit again? Revenue minus cost. Let's just do it. Pi of x, we have those two formulas. It's r of x minus c of x, which is minus x squared plus x over 4 minus the quantity, 1/2 x plus 1,000. Should we simplify it? No. Because if I show you this and I say, well, what's their revenue? You can actually tell me what the revenue is based on the first part. If I simplify it and squish it all together, you're going to lose that information, right? Simplifying a profit function means leaving it in whatever form that's most simple for you to use. And if you want to know what the revenue and the cost is, it makes more sense to leave it like this than anything else. So that's kind of like the common sense reason. There's also a very mathematical reason why it's not always a good idea to simplify. Let's use the function f of x equals 3 times x minus 2 times x plus 1. And g of x is going to be the function minus 2 times x minus 2. Two polynomials. What's the domain of f? Polynomial. What's the domain of a polynomial? This is a good review because this is chapter 4. This is going to be on your next quiz. What's the domain of any polynomial? So if you said it, say it again louder. Are there any numbers that I can't put into here? I can put anything in. So what's my domain? Negative infinity to positive infinity. All real numbers. What's the domain of G? What's the domain of G? It's a polynomial. It would. Yep. I can put anything I want in there. Now let's do f divided by g of x, which is f of x divided by g of x. What kind of function is f divided by g of x? What kind of function is that? You all have the Wednesday sleepies. Oh. The ratio of two polynomials. The ratio. Rational function. It's a rational function, and it looks like this. Agreed? Can I simplify this? I have x minus 2 in the top and the bottom. So I could cancel those. But before we do that, what's the domain of this function as written? Or where are the problems with this function? 0 and 2. I can't divide by 0. I can't divide by 0, right? So x can't equal 0 and x can't equal 2. So the domain must be everything except those numbers. So I cut them out. But if I had written the simplified version, what would you tell me the domain is? Everything except. And you're missing the problem. Don't simplify combined functions for 6.1 or 6.2. Because the domain of a combined function, whether it's function algebra or composition, so the domain of a combined function must be of a combined function must be the numbers that work in both individual functions and in the combined function. I'll give you one more example, and then I think I'm going to turn you loose. Here's maybe a slightly simpler example. Let's do h of x equals x squared plus 4. What kind of function is that? Quadratic, what's its domain? Exactly. And k of x is a square root of 3 minus x. What's its domain? I'm going to have to change one of these, but I won't change them yet. What are the problem numbers in a square root? 3 would give me 0. Unfortunately, I can do the square root of 0. Yeah. What if I increased that, like to 4? Can I do the square root of 4? I cannot. What if I made it smaller? If I made x equal 2? Yeah. Do you remember how to figure out the domain for a radical? You set the inside equal to 0. The inside has to be greater than or equal to 0. So 3 has to be greater than or equal to x. Does that make sense? Okay. So 3 greater than or equal to x means the biggest it can be is 3. And the smallest it can be is negative infinity. So now let's do h plus k of x. This is okay because we're not actually going to simplify this one anyway. Like we could. No, we couldn't really. That's x squared plus 4 plus the square root of 3 minus x. And what's its domain? Does it include minus infinity up to 3? Yeah. What about anything bigger than 3? No. Even though it works in the first part, it doesn't work in the second. So the domain must work in both individual functions and the combined function. Okay. What's h divided by k of x? That's x squared plus 4 over the square root of 3 minus x. Is the domain the same? What happens if I put the number 3 into here? I get 3 minus 3, which is, I get the square root of 0, which is, and then I divide by, which I can't do. So this domain does not include 3. It has to work in both individual functions and in the combined function. I think maybe you've noticed the problems tend to occur when we do division more often than anything else, right? Because that's when you get the sneaky, oops, dividing by 0, when before maybe you didn't care about having a 0. Don't simplify. And the domain of a combined function must be the numbers that work in both individual functions and in the combined functions. Those are our cheat codes for section 6.1 and 6.2. And with that, I will turn you loose. We're here to help.